Good day! Today I ask you how many 5-element subsets of A, which is the set composed by 1, 2, 3 until 10, so the first 10 natural numbers, contain at least one odd element. So, this set given, how many 5-element subsets are there containing at least one odd element. Okay, so basically this exercise is not difficult, not at all. It only requires a bit commitment at the beginning, because you shouldn't give up just after reading the text and say, oh no, it's too difficult, I won't solve this exercise. No, you don't give up, you just keep thinking and you will find it's not so difficult. You just have to figure out the real meaning of this condition. If I ask you how many 5-element subsets of A are there, you will answer without any doubt. So there are exactly 10 binomial 5 subsets of 5 elements in A. That's absolutely immediate, okay? But now I want to ask you how many of these contain at least one odd element. For example, the subset 1, 3, 4, 5, 10, 1, 3, 4, 5, 10 contains exactly 3 odd elements, or 1, 2, 4, 6, 8, 1, 2, 4, 6, 8. This subset contains exactly one odd element, the element 1. So we could wonder how many subsets contain exactly one odd element. How many subsets contain exactly 2 odd elements, and so on. How many contain 3, how many contain 4, how many contain 5. It's feasible, let's say feasible, but it's a long way. So this could be enough to make you look for another way to get to the solution. And there is another way, and it is to change your point of view, to think about a different point of view, and to think about the opposite condition, as often happens in mathematics. So we don't wonder how many subsets have at least one odd element, but how many subsets do not. Okay, how many subsets do not fulfill this condition? And you will find that this is far easier, because how many subsets do not contain any odd element? Only one, which is the subset 2, 4, 6, 8, 10. But because this is made only of even element. So only one of them does not contain at least one odd element. It contains only even elements. Okay? These two considerations given, the solution is done. And so it's 10 binomial 5. You take one away because it is the only subset that does not fulfill the condition, and you just solve, making your calculation. So 10 factorial divided by 5 factorial times 5 factorial minus 1. So 5 times 2 is simplified with 10, 4 is simplified with 8, 3 is simplified with 9, and you get 252 minus 1, it's 251. So the exercise is solved. Now, as for our vocabulary corner, we have learned 2 new terms. Well, probably we have revised 2 terms that you already knew. So, odd and even. One the opposite of the other. So, the numbers 2, 4, 6, 8 are even numbers, whereas the numbers 1, 3, 5, 7, etc. are odd numbers. So, an odd number is a number which you can divide by 2 and it gives the rest of 1. An even number gives the rest of 0. So, okay, so odd and even numbers. By the way, it is worth to remind that odd is an adjective with another meaning. Odd also means strange, weird, with a sort of negative connotation. So if something is odd, it is strange but you don't really like it. It's something that you are suspicious about. For example, in Harry Potter and the Chamber of Secrets, Malfoy meets his two friends Crabbe and Goyle, and he tells them, "Oh guys, you are acting very odd today," and he doesn't like the way they are acting. Actually, they are not Crabbe and Goyle, they are Harry and Ron, with the appearance of Crabbe and Goyle thanks to the Polyjuice potion. I am mad keen on Harry Potter. Okay, so thanks for watching. See you. Bye.